In this example, we're given the half-life of tritium, and then we're asked how long it will take for the sample of tritium to decay to the point that only 10% of the original sample remains. Now, it may seem like we don't have enough information to solve this problem because we weren't given the initial amount. However, anytime we're given a percentage, like we are in this problem, the easiest thing to do is just assume that we start with 100 grams. We could assume we start with any amount, but 100 grams makes it easy. Because if we assume we start with 100 grams, then that means that N0 is 100, and then NT is going to be 10 grams. So the other thing we need to do to solve this problem is we're given the half-life, but of course we need the rate constant in order to solve this. But we have this equation that relates the half-life to the rate constant. So the first thing we're going to want to do is get K. So K is equal to 0.693 over the half-life, so that's 12.3 years. And so we get a value for K of 0.0563. And the units on the half-life were in years. And so the units on K are always the inverse of the units on the half-life. So my units are going to be 1 over years. Or instead of writing 1 over years, sometimes what you'll see people write is years to the -1 power. All right, so I'm going to go on to the next page to give ourselves a little bit more room. Okay, so I've just collected the information that we had from the previous slide. We have the rate constant. We're going to assume that N0 is 100 grams, so that makes NT 10 grams. So I think we're ready to plug these things into our equation here. So NT is 10, N0 is 100, and then we have e to the minus 0.0563 and t. Okay, so the variable that we're solving for is in the exponent. So the first thing we want to do is get the exponent on the side by itself. So first thing I'm going to do is divide both sides by 100. So I get 0.1 is equal to e . Okay, so now that I have the exponent on the side by itself, to get rid of the exponent, I'm going to take the natural log of both sides. All right, so on the left-hand side, the natural log of 0.1 is -2.30. And then the e and the ln essentially cancel each other out, and so we bring the exponent down. And then the last step is divide by -0.0563. So our time comes out to be 40.9, and then the units, right, our K was 1 over years, and so the time is going to be in years.